next we'll see the concepts which help us in understanding how to convert the given double integral into the polar format and right to solve, right? So that's our objective for today, right? Solving the double integrals in polar form. Okay, so this is a concept, right? Normally, whenever we have a function given in terms of x comma y, you can convert this into the polar format wherein you get the two polar coordinates, right? One is a distance and one is angle. Okay, so here both x, y are the distances, right? Whereas in terms of r and theta, okay, I'll write separately. The theta is an angle and r is the distance, right? So this is change of your coordinate system, right? This is called as a change of your coordinate system, right? Again, actually, why do you need a change, etc.? They are actually applicable in physics, electromagnetics, and subjects like that, right? Because you will not be able to solve certain types of problems, right? Real time with the real time data in one of the coordinate system, you have to change it. Okay, so the change is requirement, right? Whenever, right, such issues arise. Right, now let's quickly look at what do you mean by this change of coordinate system and what is r and theta. Okay, so just to understand that, let us consider the coordinate system like this. Okay, I have x by standard, this is x-axis and the y-axis, correct? Now let us try to mark a point here, right? So this point, let me try to denote this as P of, okay, so we are still in the Cartesian coordinate system or the rectangular system, so which needs two distances to reach that point from the reference point that is called as origin. Okay, so denoted as O. It's irrespective of the coordinate system you use, this O is always 0, 0, right? We don't have to worry about will the origin change, right? It will not change. It will not change, right? Okay, now, so that means according to this system, right, whenever I try to measure the x distance, right, that is the distance along x-axis. Okay, so distance along x-axis in the sense how much I should move along the x-axis to reach this point. So this distance is the x value. Okay, and how much I need to move along the vertical or the y-axis to reach the same point, right, after moving so much in the x-axis is the y coordinate, right? Is the distance along y-axis. This is the normal. You see, this forms a rectangle, so the name is the rectangular coordinate system, right? So that's what we know now. Now let us see how do I get into the new coordinate system if at all I have to reach, correct? So let us say, okay, let me change the color. Now I measure a distance, but not along x and not along y. It is the direct distance between the origin and the point. Let's say if I'm able to measure this for by using some technique, let me assume I'm able to do this. Okay, this is what is the r. Okay, what we are converting now, right? We have x comma y. I want to convert that into r theta, right? So you see, it's not always required to represent a point in space by using distances only, right? You can use other fundamental, right, quantities such as angle, correct? So now you see, r is fine, but I just have to say where r you should measure, because the same r can be measured somewhere here also, right? See, this is also the same distance r on a circle, right? This actually could be something like a circle. If I simply say r, right? I need another coordinate to reach this particular point P, because right, when I simply say R, this is this actually includes all the points on a circle of radius R, right? When I simply say R, but I need to reach the exact point P, right? For that I need another, right, variable to represent, that is how much angle with respect to some standard axis. Most preferred one is with respect to plus x-axis. So positive x-axis, that is the theta. Now you see this is only one point. Making an angle theta at a distance of r, you have only one point, which is P, right? If you change theta, definitely this point comes somewhere here, which is a different point, correct, at the same distance, right? If you change r, this could be, if I reduce r, you may reach here. You see this is different theta, sorry, different point. At the same time, increase r, you may reach here. So likewise, if you change x comma y in the coordinate axis, which consists distances as distances for measurement, my question, I have a question. If you are using the rectangular coordinate system xy, are you able to cover any point on the sheet of paper? Will you be able to cover any point? Why not? See, this is a paper. I'm writing it on a paper now. Will I be able to represent? See, will I be able to read this point? It will have some x and y, right? Maybe positive, negative. Will I be able to reach this coordinate, this point, this point, this point, any point, right? Any point I can, right? So that was my question. Will you be able to reach any point on the plane in which you are actually doing the calculation or representation, right? Will you be able to reach? Yes. So you can see x can vary from minus infinity to plus infinity, y can vary from minus infinity to plus infinity. If you do that, right, you will be able to reach any point on this particular plane. If you want to move out of the plane, yes, that's also possible. Simply add another z coordinate and, right, keep going. Z also will vary from minus infinity to plus infinity, right? So as of now, so this concept is just the double integral for the time being. So let's restrict to only two axes. Okay, definitely third axis is possible, but let's restrict. Okay, now my next question is that similarly, that means just now we told we can reach any point on this plane by changing x and y. So my next question is that similarly, if I want to reach any point on this particular sheet of paper, what should be the range of r and what should be the range of theta? Yeah. Can you try to guess that? What should be the r? What should be theta? Consider that this particular. Okay, I'll slightly move this to the center so that you can consider this is at the center of the paper. Okay, so now you consider this diagram. Okay, that means I'm actually no, right now this looks like 45. So my question is that if I want to cover this point, this point, this point, any point on this particular paper, right? Like that, that's my question. What you see previously, I'll just repeat my previous question and answer. I wanted to cover any point on the plane, so I saw that x can be minus infinity to plus infinity. Minus infinity will move this to the leftmost point, plus infinity will move this to the rightmost point. Similarly, y can be also be minus infinity to plus infinity. Okay, so that you could reach the complete, right? You could cover the complete the entire region of this paper. Perfect, right? Okay, likewise, I have the same question, but now it is not in xy coordinate axis. I am right now present in the r theta, right, axis. R is a axis, theta is an axis, you can consider. Okay, so theta measures distance, theta measures angle, r measures the distance. You should be able to point out any point. You should be able to mark out any point on this particular plane. Consider that right now I am marking a point P in the first quadrant. Okay, but if I move to second quadrant or move to the third quadrant, right? Third quadrant very close to zero. Zero in the sense origin. Third quadrant very far away from the origin. Similarly, fourth quadrant very far away from origin. What should be, when you cover all these points, you will come to know that what should be the range, right? What is the minimum value of r? What is the maximum value of, like previous answer was minus infinity plus infinity, right? So similarly, what are the minimum and maximum values of this theta and r is my question, right? Just guess. So you are saying that, okay, let me write, we'll verify, we'll verify, or if there is some change to be done, we'll rectify. Okay, so you say it is minus infinity to plus infinity. Okay, tell me the theta. Okay, so theta is equal to 0 to 2 pi. All right, 360-degree, perfect. Okay, now let me say, okay, minor correction is required, almost perfect answer. Okay, so let me ask you a question. Now you said that, okay, the P point which is here, let me try to denote this as, let me try to denote this. Let me call this is equivalently on the r comma theta, right? That representation. This is like P of some r and some theta. Is it okay? Now, if at all I want to point out a point which is on the other side of this, like third quadrant, somewhere here also, if I have a same distance r and same, right, maybe the theta, right, which I'm measuring, right? So how do you represent this point in that case? P of, so you see, do you need a minus infinity, right? Right, so in this case, it's only 0 to infinity, correct? Because only theta will change. Right, when you move the theta, this was some theta, you moved the same thing on the circle to other side, you reach the other point, right? So only theta is changing, r is not changing. So right, so that should be the idea here. Okay, so r is always considered as positive quantity and theta will change, right, appropriately to cover all the points in space. Right, you want to move far away from origin, make r as large as possible. Okay, you want to cover the point which is very close to the origin, irrespective of the quadrant. So which quadrant it is will be covered by whom? Covered by theta, correct? So I don't need the r to be varying from minus infinity to plus infinity instead of, right, just change that from minus infinity, it's not required, it's just the 0 to infinity. So I think this is very clear, I hope, right? Okay, so you understood. Now let me say I want to convert, right? So if I have x comma y given, how do you get the r comma theta, right? So let's use this. The this triangle, let's try to use, right? So from the given diagram or the given graph, can I write the r is equal to, so I want a distance r, I want this distance r. Normally you say that r is equal to, use a, see this horizontal distance here is x and this is y, correct? Am I right? Because x can be anywhere, right? I can mark anywhere. So I can write r is equal to, right, root of x square plus y square, isn't it? Right. Similarly, theta, right? You can use a ratio, tan theta is equal to y by x, correct? So theta is equal to tan inverse y by x. Are you okay? So this is how I convert. Okay, at the same time, now you assume that you don't know x and y, but already the given data is present in the r comma theta format, right? I want to come back to xy, right? So what is x in terms of r and theta? Because just now you observed, I use both the given coordinates to get the other coordinates. You see, I use both y and x to reach r and theta. In a similar fashion, now I need, so you see, this is a right angle triangle. This square plus this square equal to this square, right? So we can actually derive it in many other formats also. Let's try to keep it as simple as possible, because as of now our intention is not to study the polar system. Our intention is simply to solve some problems using that. So I'm trying to keep it as simple as possible. Okay, right. So next, how do you get the x from, you see, only r and theta are given. I don't know what is x and y. You need to find out. So use the same properties of triangle. So if I want to calculate the x, so find the relation between x, r and theta. So right, x by r is equal to cos theta, correct? So x should be r cos theta, right? So similarly, I can come back to y by using r sin theta. That's all. You see, you have a very easy equation to convert, right? Any one is given, I just have to find it into the other. Okay, right. So this is one part of our discussion which actually deals with the interconversion. What is the x? What do you mean by r comma theta or the polar format? How do you convert one to the regular format into that format? That's the first part. Okay, and if the r theta given, how do you come back is the second part. Anyway, we understood that. Okay, but when it comes to the differentiation and integration involving the polar coordinate, given that you have the xy coordinate with you, we need an additional part to be discussed. That is, what is, see, if I have xy, I have the variable of integration defined as dx and dy, correct? That's right. But what happens when I convert that into the polar coordinate is my question, right? It will change, limit will change, right? I'll come to the limit slightly later, but initially I want, say, this is my question. So I have a I given, I is equal to, right? Some regions are defined. Let's look at the region later, no problem. I had a function f of x comma y dx dy, right? Right. So now you see this is equal to, this is again double integral. I will be using some other region. I'll denote by r dash, or you can even r cap or whatever, doesn't matter. It's a new region now. New region because area still remains same, but the representation changes. It's in terms of r and theta, right? So though you are representing the same region, actually, I can even write r, but I don't want to get confused, like how the r still remains same, because since xy becomes r theta, something should change. People expect that, so I don't I want to avoid that confusion here by saying keeping r same. Let me change it. So there is a r dash, some other region. Now you see this f becomes some g of r comma theta, some other function, right? That's fine. Anyway, this conversion we know now, right? Put r is equal to something, put theta is equal to something, you reach this. Okay. So using this previous concepts, anyway I have converted, right? So put, right, instead of x square y square, I put r. Wherever I had this thing, I can come. So otherwise, x replaced by simply r cos theta, y replaced by this, you got an equation in terms of r and theta. Okay, that's absolutely fine. But now you see what will happen to dx dy. Dx is nothing but change in the x, right? Change in x is, so this dx dy is not equal to simple replacement of dr d theta, right? Are you understanding why? Correct. So because you see r is equal to root of x square plus y square, means if you do a dr, you get a function here, right? It's not a simple, I don't get a dx over there or dy over, correct? When I differentiate dr, I don't get that, right? Similarly, you have some equation for theta. If you perform d theta, you don't get a simple dy over there. So I cannot do the simple replacement. That's what is the point. All right, okay. So that's why dx is not equal to dy. I have to write one particular thing here. Anyway, I'm going to come to the dr d theta ultimately, but there is another parameter that I need to consider, how the r and theta vary with respect to x and y, correct? Because anyway, dx dy is change in x and change in y. I am trying to replace change in x and change in y, the product of dx dy, by dr d theta. It's absolutely allowed in mathematics, provided you also write another parameter, like so into, right? So this is anyway, I'll write dr into d theta, but I also need to multiply by a factor saying that this is partial derivative. Okay, how x comma y vary with respect to r comma theta. What is this notation? Somewhere you have seen this notation, correct? It's simply, if I write dou x by dou y or dou x by dou r, it is a partial differentiation. Okay, But you see, it's not simple partial differentiation. I have dou of x comma y means the function of x comma y with respect to the partial variation in r and theta. So there is a this is actually not a simple what you call partial derivative. It's not a simple one. There is a name for that. So if you have heard or you are able to recall, try to guess. Yeah, sure, sure. Please take your time. No problem. Sorry. No, 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 no. Not related to them. So I think you might have studied one chapter uh, under the category of partial differentiation, right? Somewhere where you actually see what is this. There is a name for that. If I write a notation, are you able to recall? This is called as a J. Uh, anything, anything comes up into mind? Special function possible under special function it might have might have been in yours, right? Right. So actually, this is called as the Jacobian. Have you heard the term? Okay. Now they are teaching. Okay, Jacobian. Right. So that is what is called as a Jacobian. Right. So Jacobian is actually a tool used to. Now this makes sense to you because Jacobian is a tool which is used to change the coordinates. Right. Now you see, actually you are doing the same thing. Jacobian is a simple like a Fourier transform, right? Like when you want to change from x-axis to f-axis, frequency axis, you use Fourier transform. Okay. Likewise, I don't want x comma y. I want to jump into a new coordinate system, right? Which is maybe r theta, right? So fundamentally, you are trying to replace the coordinates xy by r theta, dx dy by the corresponding things. But I also need to multiply how your original, right, uh, dx dy changes with as r and theta when you want to replace that component needs to be multiplied. Okay. Right. So that's why you need this component called as dou x comma y, original, in the sense whatever you had in the first place, x y, right? Partial derivative of that with respect to this. Now I'll come back, right? So that means anyway, my intention is what do I replace with respect in place of dx dy? That was my point. Anyway, so let's do the calculation quickly. So there is a j. It's j. J is equal to, as I denoted, this is partial derivative of x comma y with respect to r comma theta. So this means it is actually a determinant dou x by dou r. Since it's being covered to you, you should be able to relate, right? So this is dou x by dou theta. See how much x varies when r is changed, how much x varies when theta is changed. That's what is the first rule. Similarly, this is dou y by dou r. This is dou y by dou theta. That's all. So you take a determinant. Okay, so anyway, we know what is x and what is y, correct? What is x in terms of r and theta? X equal to r cos theta, y equal to r sin theta. So just tell me this answer. What happens? So dou x, which is r cos theta, divided by dou r, right? That is simply cos theta. Dou x by dou theta is, right? R is a constant. So cos theta becomes minus sin theta, minus r sin theta. So dou y by dou r, right? So r, so this is sorry, r sin theta. So this becomes simply sin theta, and dou y by dou theta becomes r cos theta, isn't it? So it's a normal 2 cross 2 determinant to be solved. So this is r into cos square theta, minus of minus cancels, plus r square, not r square, just r. Take, yeah, r into sine square theta. I'll take r common, right? Cos square plus sine square equal to 1. So this is 1 into r. So the answer is r. So that is the j value. I understood. So that means overall this is the conclusion after all this, right? If you have a dx dy in the xy coordinate system, right? simply replaced by r dr d theta. That's all. You convert your function f into g, where g is in terms of r and theta, replace the dx dy by r dr d theta, right? Definitely you need to change your limits. What is the limit of r, right? According to the given problem, what is the limit of theta for solving the integral for this given problem? Okay, I hope this is fine. Do you have any doubt? Please let me know, otherwise we'll start solving the problem. Okay, all right, directly go to let's go to the problem. Okay, so this I is equal to integral 0 to infinity, integral 0 to infinity e to the power minus of x square plus y square dx dy. Solve all the questions belong to the same category. Solve by using the polar coordinates. Are you okay? Right. So anyway, you don't have to, in the sense, most of the time the graphs etc are not required here because the conversion is pretty straightforward. What is the conversion? Conversion is like, put, I need to bring r and theta, so replace x and y accordingly. What is the x? X is equal to r cos theta. No, I'll tell you how. Okay, no problem, right? So x is equal to r cos theta, and put y also is equal to similar replacement for this r sin theta. Okay, and I also have another relationship which is normally found useful, is the same thing which we discussed already, that is x square plus y square equal to r square, and the dx dy you simply replace it as r dr d theta. Right, now you understand one point, like when I asked you to convert from x comma y maximum minimum to r and theta maximum minimum, you answered directly as, right, how you decided what happens with r, right? You told r also minus infinity to infinity, but anyway ultimately you know now that if both x and y, yes, so if x and y, remember this point, in this case, the given problem, let's look at that once again. So first variable is y is equal to 0 to infinity, right? And x is also varying in the same way, right? X is also equal to 0 to infinity, correct? So look at this. As we understand, this is in which quadrant? X 0 to infinity, y 0 to infinity. Which quadrant it is? Right. Yes, both are positive. So it has to be first quadrant, correct? Now, in the sense, you are trying to cover almost every point in the first quadrant, right? Starting from the point which is close to 0 till the point which is close to infinity, right? Both are being covered. That means what should be the range of R? R is a infinity. So X, I'll make a statement like this. X comma Y vary in this problem, okay? From 0 to infinity. This implies, I'll make a decision, R also will vary from 0 to infinity because of the same reason. Just now I have to understand which quadrant it is most of the time, right? Most of the time xy given, you see where is it and decide the R. Hope this is suitable, right? Now anyway you know the complete first quadrant. This is covering the complete first quadrant. X is 0 to infinity, y 0 to infinity, means it is complete first quadrant, isn't it? R might change, doesn't matter, but still you have to cover the complete first quadrant, right? That means, right? So also, what is the range of theta? Already you told, I think 0 to, perfect, 0 to pi by 2. Okay, let's substitute. let's substitute this. Let's make the changes in the integral. Therefore, I is equal to double integral, right? So uh, I'm going to write r dr d theta, right? So that's my dx dy is directly replaced by r dr d theta. So d theta comes out, so theta will be written first. Okay, so theta is equal to 0 to pi by 2, right? R varying from 0 to infinity. Okay, e to the power, you see, minus is there. There is a x square plus y square in the bracket, which means it is simply r square, correct? Into dx dy is r dr d theta. You see the question has a minus outside. You see, it's minus of x square plus y square. So now it's no more any complicated question. It's simple integration with the two variables. That's all. Okay. Are you fine till here? Okay, yeah. Take your time, solve this, then we'll compare the answers. So when we solve this double integration, we're going to get an answer that is equal to pi by 4. Right. Let's move further. The next question. So it's actually as simple as simply solving a normal double integration, but the idea is to convert the limits properly. That's all, right? Yeah, I'm solving another problem, slightly next level. Okay, so the next question is this, right? Because when xy limits are given, xy always belong to some quadrant. Sorry, correct? It's some quadrant. You just have to identify and convert that quadrant into the required r theta, right? Again, r theta will not always vary from like 0 to 2 pi, or no fixed values there. I'll show you now. Okay, right. I'll show you. The next problem I'm going to solve, which is slightly of next level. So this is C, minus a to plus a, and integral, this is 0 to root of a square minus x square, to this is root of x square plus y square dy dx, right? Solve by converting this into the polar coordinates. Okay, now this means I have to decide what happens with r, right? So let me see. So x is minus a to plus a. So x takes a negative value as well as the positive value, right? So along x-axis, if I try to, let me say this is the, okay, draw the neat graph. It's actually, in the sense, I am not able to, by just looking at that, I am not able to decide which quadrant because of this given data, because, right, you understood now that this could be all the four coordinates, sorry, all the four quadrants, right? See, I write this is plus a, this is minus a. Any point here will have positive and negative a, right? X-axis. But what about this? That they are also going to get the same negative a, and no, I didn't come till there. I'm just looking at x, and am I able to decide what happens, which quadrant it is? That's my question. As of now, not possible. Correct? If you look just about the x variation, no. Correct? Now, yeah, now you come back to the, now that's why in order to cut the coordinate short to lower number, right, I'll use the y. So as I can see, so this is the x first, let me write, a is minus a2, so y is 0 to positive, right? So right, 0 here, y is 0 here, right? To the positive means it is here, so correct. So look at that, what is the y in this range, right? Because they have given y is equal to root of a square minus x square. So right, so try to convert this into some standard equation so that I can understand what is happening here, because they may be covering a triangle, possible, right? So you see, x square plus y square equal to a square means they are talking about a circle here, right? So they are trying to cover a circle in this region, right? So now you see this is the region they are talking about. So you see what is the radius r now. So okay, let me write y is equal to 0 to root of a square minus x square. So this implies now I am able to decide what happens to r and what happens to theta. So r is only positive. So minimum point which is closer to this or on origin will have r equal to 0, right? So a point which is on the circumference of this particular circle will have a value, right, that is equal to a. Are you fine? R is varying from 0 to a. Right. Now you tell me what is a theta. It's not a complete circle, it is half circle. So theta should be minimum is 0, maximum is pi, 180. Okay, pretty straightforward. Let's come back. Let's come back to the problem. Let's try to substitute. So this implies the same I, I'm going to write it in. So I is equal to integral. So theta varies from where to where? 0 to pi, I guess, right? Okay. Theta is 0 to pi, and the radius varying from 0 to a. I think this become very simple problem because root of x square plus y square is nothing but r, right? That's the question. Into I think we have r dr d theta, so I'll write r square dr d theta, right? So very simple. Please go ahead. Right. So when we solve this, we get answer as a cube to pi by 3. Okay, that's the correct answer.